Hey everyone, my name, as introduced, is Kshetrajna. It is a hard name to pronounce. Most people at Shopify call me, which is my first alphabet. If you want to talk to me, call me K. It's easier that way. Today I'm going to talk to you about a journey, right? And this is the same journey our merchants take with us every single day, and I'm going to talk to you about how we use different machine learning models along that journey to make our merchants' life just a little bit easier. Before I do that, a quick introduction on Shopify. By show of hands, how many of you have heard of Shopify before? Okay, great. And for those of you who haven't heard of us before, Shopify essentially is a platform which provides all the required tools for you to run a commerce business. We started way back in 2006, and we've grown. Clearly, those numbers show you how much we've grown. We now operate pretty much in every country in the world. Most of you would have at some point purchased something from a Shopify merchant, whether that's in person or online. You would have purchased something from a Shopify merchant, except you probably didn't realize you were. And that's by design, right? We want to put our merchant front and center. You can see some of those numbers up there. That gives you a sense of the scale in which we operate. So, a little bit about me. You already know my name. Like I said, call me K. It's easier. Or if you want a challenge, Kshetrajna. For some reason, people find it hard. I work as a staff data scientist and a tech lead over at Shopify. I've had over 10 years of experience in productionalizing machine learning models in different domains, retail, ad tech, and healthcare specifically. Thing about me is I have a very strong belief in systems thinking. In fact, a lot of today's discussion is going to touch upon that. But having said that, I'm also a firm believer in doing whatever needs to be done to solve the problem at hand as quickly as possible. But those two things aren't necessarily always in conflict. In fact, there always is a way which is both quick and easy, but also helps in iterating towards building a robust system in the long term. And that's going to be the theme of what I'm going to be talking about a little bit here as well. And outside of work, those are the things that I'm super interested in, and in that order, right? That's a little bit about me. So here's the agenda I have for today, right? So we're going to take a journey, like I said, and we're going to take the same journey that every Shopify merchant is going to take when they join us. And along the way, we're going to see how Shopify is using these interconnected machine learning models at every step of the way to make our merchants' life a little bit easier and a little bit smoother. Right? So we'll start off by talking about the different problems that you and me will encounter if we were to run a commerce business, right? Whether it's with Shopify or whether it's somewhere else, right? These are common problems across the board. And we'll talk about what those problems are. And then we'll pick a few of these problems, right? Like when I wish I could talk to you about every single problem and how Shopify is trying to address those, we don't have the time for that, so I'll pick a few of these. And we'll talk about how we're specifically using machine learning to tackle these problems. And then finally, I'll touch upon a little bit on the infrastructure side of, it's all well and good to talk about, hey, these are the fancy ML models we have, but how do you actually go from an idea that a data scientist or an ML engineer had in his head to quickly prototyping it and getting it to production, and doing it in a way that allows us to quickly iterate and scale. Right? So we'll talk about the infrastructure a little bit. So with all of that said, let's start the journey today. Right? So where do we start our journey? Right? Let's start off at the very, very beginning. Let's say all of us today have an idea and say, hey, I know this great product that I want to sell. Maybe I want to sell it online, maybe I want to sell it in a retail location, but whatever, right? We have an idea of what we want to sell. And so we're like, let's go create a Shopify store. Let's start there, right? So where do we go from there, right? So the first thing you do is you join Shopify. We have different tiers of service. You create a free store, essentially. It's a website, you create a storefront. And so where do you go from there, right? Like just having the storefront doesn't give you sales, right? Like there's a lot more that goes to commerce than just storefront, right? First thing we want to do is maybe we want to do catalog management, right? Especially in a world where I want to sell across multiple channels, right? Maybe you want to sell on your store, you want to sell retail, Maybe you want to sell it in Google, Facebook, Instagram, TikTok, wherever, right? So you have all of these different channels that you want to sell on. How do you do catalog management? Let's say you solve that problem. Then you're like, okay, I have a fancy website, I manage my products, I have a catalog. How do I actually get customers, right? In fact, this is one of the biggest problems that any Shopify store or any retail store is going to face, right? How do you find customers? Let's say we did find customers, then we want to kind of like manage our inventory better, right? Again, like I said, you're selling across multiple channels. How do you manage your inventory, right? Let's say you did that, right? Then you have to manage checkout, right? Different payments, different payment systems, all of that. Checkout comes with its own set of challenges, right? So you want to do checkout, right? Let's say you solve that. Now you're dealt with logistics and shipping, right? Like, again, this isn't easy, especially as you scale. Logistics and shipping becomes really, really hard, right? So how do you tackle that, right? And maybe our business grows so big that we want to have a bunch of automations as we scale and grow, right? And after all of that, I'm still like, hey, I have to deal with fraud and I have to deal with fraud protection, not just for me, but for my customers as well, right? And there's many, many more, right? This list can go on, right? But essentially, we can start quickly realizing how complex this journey can get, right? Running a commerce business isn't just a shop, isn't just opening the Shopify store and having a fancy website. It goes beyond that, right? There's a lot of things that go into commerce. So at Shopify, we believe in helping our merchants at every step along this way, right? And we have different teams that focus on different aspects of this. And what we've come to do in the last few years is we've realized that machine learning can help us along all of these, and ML has started to become more and more embedded into every step along this journey. And today I'm going to talk to you about some of those journeys, right? And how they're not operating in isolation, but they actually talk to each other, right? So you have all of these machine learning models that are interoperating with each other. And so that's going to be what we're going to talk about, right? Like I said, while I wish I could talk to you about all of those use cases, right, I'm going to pick on 3 specific topics today, right? First, we're going to start with catalog management, right? And how we're using machine learning to make this easier for our merchants to organize their store, right? Specifically, I'll talk to you about how we're using natural language processing and computer vision to automatically generate metadata around our products so that this is used across multiple things, right? Like things like search and discovery, taxation. There's many use cases for this, right? So once we do that, I'll then talk to you about how this ties then into enabling our merchants to do better online advertising, especially today in an ever-changing world of online digital advertising. It becomes very confusing and hard for our merchants. And so I'm going to talk to you about Shopify Audiences. This is a product we just launched earlier this year, and how these two things tie together. Right? Finally, then I'll talk to you about how we evolved from just product categorization into more visual attribute extraction. And so these 3 things will then tie together. And then, like I said, at the end of all of this, I'm going to talk to you about the infrastructure and the platform that we built that supports all of this in quick iteration. So having said all that, let's dive deeper into product categorization. And over the next few slides, what you're going to see is how these ML models are not just talking to each other, but they share commonality both at an infrastructure level and also at the model level. Right? So let's start with product categorization. For those of you who remember from my previous slide, dogs, those are my 2 dogs. So let's say I want to sell that dog bed, right? Like I've created my business, that's the bed that I want to sell, right? I want to now manage my catalog, right? The first thing you'll know, if any of us have shopped online, we know that search, like if I search dog bed, like this has to show up, and then I'm going to say, hey, I want it gray color, and I want it, I don't know, rectangular shape, and I want it memory foam, blah, blah, blah. All of these are essentially attributes, right? How do we get that, right? Like, so first of all, like I need to know that it's a dog bed. If I know that, the next thing I want to know is it's gray in color. I need to know its shape, I need to know fill material, onwards and onwards and onwards, right? Now, obviously, I can rely on the merchant to manually enter it, right? But that's both inefficient and creates friction for the merchant, right? If there was a way for us to automatically do this for our merchants, probably a better solution. And so that's where product classification came in, right? So we wanted to see if we can use all of the data we have. We've collected a lot of data around products and their metadata, and we were like, let's see if we can use machine learning here to to train a model and make predictions to extract this metadata. So before we could start doing it, we needed a control list of what categories are, right? I just said dog bed is a category, but how do I know that, right? Maybe bed is the category, right? Why dog bed, right? Why not animal bed, right? So we needed a control list of categories, and this is where the Google product taxonomy came in. Like the name suggests, Google came up with this, they maintain it, and we kind of just piggybacked on top of that. Here is a single branch of the Google product taxonomy, right? So this taxonomy isn't a flat structure, it's hierarchical in nature, right? So this is one single branch of the taxonomy. We start at level 0 or 1 with arts and entertainment, and you can see quickly how granular it gets. By the time I get to the bottommost level, it's talking about clarinet care kits, right? So we started at arts and entertainment and it gets to clarinet care kits, and this is one branch of hierarchical taxonomy, right? There are over 5,500 different nodes in this tree, which basically means there are 5,500 categories, right? And in this example, we can kind of see why we need it, right? Because we can do aggregations at different levels, right? Maybe there is, for taxation, I might need to know that it's a clarinet care kit, but for, I don't know, financial reporting, maybe I just need arts and entertainment and that's enough, right? So I can kind of aggregate at the level that I need to be in for different purposes. So this tree structure makes it very easy from a consumer perspective, but from an ML perspective, it introduces all sorts of complications and challenges, right? Like, because most of us are used to a flat classification system, which is easy, but this creates an additional layer of complication, right? And so,
is this a service that you purchased from Google, or is it?
It's Google it's an open source taxonomy that you can use. In fact, it's an industry standard at this point. Like Facebook uses it. There's a bunch of other e-commerce companies that use the Google product. So before we get into the model itself, quick note on the scale at which we needed to operate. Historically, Shopify has had billions of products that our merchants have created and sold, right? And we've collected tens of billions of images across these billions of products, right? And so every time we train a new model, one of the requirements we had from our internal consumers was that we need to perform historical backfills for all the products that we've ever sold, right? You can question that requirement, but it's just internally we needed to do that for different purposes, right? And furthermore, forget the historical backfill for a second, even just going forward, our merchants are creating tens of millions of products on a daily basis. These are updates, creates, and we want to kind of keep updating our predictions as changes happen to our products. So that was something that we had to kind of consider, right? And after all of this, there are different downstream consumers, right? Like some of the examples you see up there, right? Product sync, search, taxation, admin, analytics. There's all sorts of use cases for product categorization. And not all of these have the same access patterns, right? Some of them require us to do real-time predictions, right? As the merchant's typing in or changing things in the admin, we want to at real-time update our predictions. There are other applications where we're kind of like, hey, I don't care about those intermediate predictions, but all I care about is when the data hits the production database, I wanted it updated as quickly as possible for, I don't know, fraud use cases or something, right? So there are different use cases that have different access patterns, and we needed to support all of those different access patterns as well, right? And so those were some of our requirements, right? So what did we come up with, right? So for training, what we did some initial experimentation, and we made a decision to build a model that wasn't task specific. And what I mean by that is our vision was essentially to build a knowledge graph, which we called the product understanding engine, right? And the idea behind this was that similar tasks need not be learned from scratch, right? And learning from one task can help in learning the other, right? And we touched upon it briefly in one of our previous slides. Why should learning, let's say, color of a product start from scratch when I already know it's a t-shirt? Like if I'm understanding that a product is a t-shirt, maybe I also kind of understand what color it is, or maybe there's some commonality in those two tasks. And so can I not start from scratch every time? Can I build something that's common across those layers and then kind of piggyback on top of that, right? So first of all, we started by framing this as a multitask, multi-class classification problem. Um, and again, like I said, the idea was to have this central layer of different central network of layers, and then we can kind of, for each task, make the required connections between these layers to tackle specific tasks, right? And then specifically for product categorization, what we did is each level of the taxonomy is treated as a separate learning task, right? So remember that dog bed? Dog bed is a level 4 category. Level 1 category, I think, is animals and pet supplies, right? So predicting that that product is animals and pet supplies in level 1 is a different task than predicting that it's dog bed in level 4, right? So we have different tasks for different levels of the taxonomy. And each task is a multi-class classification problem, right? So at level, and the key thing to remember here is not all levels are equal, right? The number of classes at each level is very different. Level 1, for example, I believe has 21 different categories. I think level 3 or 4 probably have 1500 or so, right? So different levels have different number of categories. And then, like I said, we didn't want to reinvent the wheel, especially because we were using unstructured data, specifically text and images. So we kind of said there's been a lot of advancements made in those fields, and so we kind of tried to piggyback on top of pre-trained models. Specifically for text, we use the multilingual BERT model, and for images, we use MobileNet V2. So that's kind of where we decided from an architecture perspective, right? So we said, we're going to treat this as a multitask classification problem, and we're going to use pre-trained models to kind of kickstart our training. So this is kind of a rough schematic of the model architecture itself. You're only seeing it up to level 2, but like I said, the taxonomy goes all the way through level 7, and this graph will continue all the way to level 7. And without getting into very specifics, what we do is we feed the text and the image for the product into their corresponding embedding layers, right? So BERT and MobileNet V2. And what we then do is we take those embeddings and feed it into a multi-layer perceptron model that kind of predicts the first task, right? So the first task in this case is the level 1 output. So for our dog bed, it's going to predict, or hopefully predict, animals and pet supplies, right? What I then do is I take the output of that layer, concatenate it back with my original inputs, and then go through another multi-layer perceptron to predict level 2 and onwards and onwards and onwards until I hit level 7 or a terminal node. Right? So, like I mentioned earlier, there are different levels in the taxonomy. The one thing to keep in mind here is during this stage, the model is completely taxonomy unaware, right? As in, nothing stops the model from predicting, let's say, animals and pet supplies at level 1 and then going and predicting drill bit at level 2, right? We'll come back to that. During inference stage, we do something to kind of prevent it, right? But at this stage, yes, we feed in the top layer to the top level prediction to the bottom to kind of try to influence it, but it doesn't guarantee the parent-child relationship in the taxonomy is respected. We influence it, but there's no guarantees.
Is the embedding layer also trained?
Yes.
Can I ask one question?
Yes.
The raw text, is that usually the product descriptions or names?
Yeah, there's a few different fields, title, description, tags. There's a bunch of fields that come from our admin page, but yeah, essentially mostly title and description.
And is the training simultaneous for every layer or consecutive?
It's simultaneously done for every layer. Like, it's essentially treated, like this whole thing is treated as a single model and we train it together. So during the back propagation stage, each level output is going to have one loss function associated with it. But again, like the combined loss is then aggregated and the gradients are calculated that way. So we did training, right? And now what do we do for prediction, right? So one of the things we knew is we would always start with the raw text of the image, right? If it's the first time we're seeing that product, we would start with the raw text of the image. So again, remember we spoke about the scale, right? We spoke about how many billions of products and billions of images we've had and how many millions of products we are creating every day. So cost was a consideration for us, right? Like it would be very easy and lazy of us to kind of say every time I need a prediction, just start from scratch, take the raw text and the raw image and make a prediction. I could do that, but it's very expensive, right? So one of the things we wanted to do is cache the embeddings if possible, so that the most expensive step in that architecture is the embeddings, right? And so if possible, we wanted to try to see if we can cache the embeddings, right? And so what we did is we essentially, once the training is complete, we kind of took that big model and then split it into smaller chunks, right? So we saved the embedding layers as their own standalone models, right? And we said, hey, every time you get a raw text and a raw image, just pass them through the embedding layers and cache the embeddings, right? And so once you have those embeddings, then you send it to the chunk of your model, which let's, for the sake of simplicity, call embedding to probability, right? So this is the multi-layer perceptron layers that you saw after the embedding layers, right? So these will essentially, remember we have multiple tasks, so you'll have the outputs from all of those tasks coming out. Specifically for product categorization, we had 7 levels, so 7 tasks. So it will output 7 different vectors of varying lengths based on how many classes we have per task. And so that's all of the logit scores for each category in each level, right? And once we have that, then we kind of go saying, okay, I have all of these different logit scores for all of these categories. How do I select the prediction? And this is where we kind of come back. Remember I said we were taxonomy unaware during training. This is where we kind of enforce the category, right? Enforce the taxonomy. So what we do is we go in and say, hey, I know you predicted animals and pet supplies in level 1. So regardless of what the logit scores at level 2 are, the prediction from level 2 can only be a child from the level 1 prediction, right? And on and on and on, right? So we just walk down the taxonomy to make sure we now have a prediction that respects the taxonomy itself, right? And so we have all of these different standalone models. Each of them is their own thing, right? And I can then deploy it as I need to, right? So let's say I want to do this in real time, then I kind of package up the whole thing and deploy it as a single model object. And so that way, give me the raw image and the raw text and I'll give you the prediction. Or maybe you've seen that image before, and so now I want to kind of use only the second half of that model object. So I take the embeddings from my cache and then send it to the rest of the model. So now I'm able to do all of that, and this actually results in quite a bit of savings, both from a compute as well as a cost perspective. And so these are essentially the foundational fundamental pieces that we have in the model, and we can kind of, like I said, we can start and stop along any path in that flow. Right? So we did all of this. We built the model. We've deployed it. Now it's running. How do we measure performance and impact? Right? Obviously, we have a bunch of ML metrics that we kind of track, and these are standard across. The fact that it's hierarchical introduces a little bit of more complexity, but it's nothing that we cannot solve. But more importantly, we didn't want to just focus on ML metrics. We wanted to kind of see, was this being used by our merchants? Did they actually find value out of it, right? And as you'll see in a bit, we have many internal applications that use these categories that we predict, but we also wanted to put all of these predictions in front of our merchants and see if they find value out of it. So what we did is essentially, what you're seeing here is the admin page, right? If you were to create a Shopify store and then you want to create a product, this is the page that you will see. So in this case, I'm creating that, creating the dog bed product, and you see in the bottom right over there, you see dog beds pop up. That's our prediction, right? In real time, we've popped that prediction up, and our merchants now have the option of either accepting our prediction. They can choose to correct us, right? So they can go down there and then they can say, hey, this isn't a dog bed, it's something else. In which case, we immediately use that as future training data to make our model better. Or they can kind of ignore it and not do anything about it, which is, yeah, it's the worst possible outcome, but it's a possibility, right? And so we kind of measure engagement here, right? And so the goal is to kind of incentivize our merchants to kind of engage with that field. And they have plenty of uses for this. Taxation, for example. Like if you kind of, if you adopt that prediction and if you kind of fill that for us, then we can automatically do taxation for you, right? Because especially in the United States, what you sell influences how much you should be taxing that product, and it varies across state lines. It's a very complicated problem. So we can do a bunch of workflow improvements for our merchants if they kind of adopt that field. Right? And so we've now reached that end of that first stage of our journey, right? We've seen how we use machine learning to do automatic product categorization, and we've found some merchant use case out of it, right? So we now have a fairly reliable and scalable way of inferring what kind of products our merchants are selling. Where do we go from here, right? We kind of looked around to see if there are any derivative use cases that we could come up with. And we actually found one that was staring at us in the face, right? And this is the story, and the next step of our journey today is going to be the story of Shopify audiences, right? So again, let's go back, right? So we've created our product. Our fancy machine learning model has now helped us categorize that we're selling a dog bed. What's my next step, right? Well, I have to find somebody to sell it to, right? Like somebody now has to pay me money to send that product over to them, right? One of the, if not the hardest problems for a merchant when they're trying to sell their product online is acquiring new customers. Right? So how do they find customers who are interested to buy that dog bed, right? Typically, you would do this through some sort of online advertising platform, right? You will go to one of the common advertising platforms. You'd run a campaign, and then hopefully you're able to drive traffic to your website. Right? Problem is, most of you are aware, there's a lot of churn and changes happening in the online advertising space. And we've seen this starting to affect Shopify merchants. Right? So we kind of looked at it and we said, hey, can we do anything that makes customer acquisition easier for Shopify merchants? And this is where Shopify Audiences comes in. So what is Shopify Audiences? Well, it's a new way for our merchants to find high intent buyers. Right? This allows them to be more efficient in how they spend their money for online advertising. So basically, the premise of all of this is that the collective power of many Shopify merchants is individually better for each one of them to get if they work together than if they are siloed away, right? But having said that, like I must point out that this is also a voluntary service. Like so merchants have to opt in to Shopify Audiences. We definitely do not use any data from merchants who haven't signed up to be part of Shopify Audiences. Right? And the reason Shopify Audiences works is because Shopify merchants typically represent a very niche market, and buyers who purchase from Shopify merchants typically are some of the most high intent customers that you will find on the internet, right? And so this is where we want to use machine learning again to build on top of product categorization to help solve a very critical need that our merchants have. Right? Without getting too much into the detail on how the specific machine learning model works, I'm going to talk to you about a high level of how audiences, the product works. So again, I said collective, right? So we've now created that dog bed, and we're now like, hey, I want to run a campaign that hopefully gets me customers who are ready to pay money and buy my dog bed from me, right? But how do I do that? Well, I'm going to go join this collective of Shopify merchants, and we've agreed to band together with other merchants, right? And this is where the machine learning comes in, right? So what we do is essentially we look across all of the buyers from across those different merchants in the collective, and we kind of go and look at all of their past purchase data, right? And Shopify knows that, right? Because we are powering all of the checkout in all of those merchant pages, right? So I know that, hey, from merchant B, like customer A purchased a screwdriver from merchant B, and customer number 2 purchased dog food from merchant C, right? So I can now go and say, hey, that second customer is probably more likely to buy your dog bed than the person who bought the screwdriver, right? So we're essentially looking at basically likelihood of purchase of that particular category based on previous category purchases, right? And so by doing that, we're able to come up with an audience set, right? So I take my big buyer pool, I look at all of their purchase history, I then come up with an audience set, and now I know that these audiences are highly likely to be interested in purchasing that dog bed, and then I send it over to the ad platform, right? So I basically say, here's all of the audience that you should be targeting. Obviously, there's a bunch of privacy concerns there, so we never ever identify, like even the merchants are unaware of who those customers are. Shopify directly sends that audience set to the advertising platform. And so this is actually all, like we rolled it out earlier this year, and it's proven to have increased the efficiency of the ad spend quite a bit. And so that was Shopify Audiences, right? That's the story of how we took product categorization, we found a derivative use case, we built a machine learning model on top of that, and it's actually solving a very critical merchant problem. So we did that. Now we've built these two different.
Sorry. No, I do not have a question.
So we've built these two different models that are kind of related to each other, and we've solved very pertinent merchant problems. How do we take it one step further, right? The next obvious step to us, we went back to product categorization. The next obvious step to us was attribute extraction, right? Remember that slide where we said, hey, what color is it? What shape is it? What size is it? Now we want to tackle that problem, right? I'm not content with just predicting, hey, this is a dog bed. I want to predict what color it is, what size, what shape, what material onwards, right? And as we saw earlier, right, we use text and images for our products. For attribute extraction, we kind of started only with images, right, because we felt that that was enough, right? And what we quickly realized is that attributes are localized to product categories, right? And what I mean by that is if I say, hey, what are the attributes for a t-shirt, right? You're probably going to tell me neck length or neck cut, sleeve length, color, pattern, blah, 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 right? Whereas if I tell you, hey, what are the attributes for a screwdriver, it's very different now, right? Like the kind of attributes you would have for a screwdriver are very different. So we quickly realized that product categories was kind of the anchor before we could get into attributes, right? Each product category would have its own set of attributes. And so right there, we kind of understood that we needed someone else, right? Like as a data scientist, I don't know what all attributes need to be for every category. Remember, there are 5,500 different categories. There's just no possible way that I'm going to be able to go in and say, hey, here are all of the attributes for each of those categories. So what we essentially did is we relied on people we call domain experts. Now for each domain, like let's say fashion, for example, we have domain experts, essentially taxonomists, who will come in and tell me, hey, for t-shirts, these are the attributes you have. For pants, these are the attributes you have. For hats, blah, blah, blah. Right? So once you have that, what they then do is they create this attribute taxonomy, and then they send it over to a bunch of manual annotators who are trained, right? So we have these annotators go through a training process, who will then create a small but high quality labeled data set for us, which is then sent over back to us, and then we pick it up from there and we train ML models. We have an automated ML training model pipeline, which will, like all our domain experts have to do is define a taxonomy and give us the data for that taxonomy, and we'll automatically pick it up and train a bunch of models and pick the best one. So right now we're only doing it for the fashion domain, right? So within, like you can see right there, right? So for the top, I'm able to say color, type, waist, blah, blah, blah. And for the pant, there are different attributes. Right? So this was essentially the product of attributes, right? And the commonality between, like I already spoke to you about how from a taxonomy perspective, it ties back to the categories, right? But even from an infrastructure perspective, it tied back to product categorization, right? Because for product categorization, one of the things we had to do was build an image download pipeline, right? I already spoke to you about how many images we have. Like we have tens of billions of images, right? And moving that kind of images for training and prediction was non-trivial, right? And so we had to build an image download pipeline. And so we kind of reused a lot of that for attributes. And on top of that, I told you that we were caching a lot of our embeddings. Those were also very useful for attribute extraction. Right? Again, do we need it? No. Is it better to have? Yes, because it results in a lot of cost savings. So lot of similarity. In fact, product categorization and attribute extraction are essentially now seen as a single product, right? They're built one on top of the other. In fact, when a new product comes in, the first thing that goes is product categorization. It'll predict saying, hey, this is a dog bed. Once that is there, then we have, like we'll automatically say, okay, this is a dog bed. I need attributes X, Y, and Z. So go run models X, Y, and Z. Right? So it's automatically, so we have this knowledge, we have this inference graph of different models that will kind of, based on the prediction from the previous model, it'll decide which model to run next, and then it'll kind of go through the system until we get all of the attributes that we need. So those were the three things, right? So these were the three things I wanted to talk to you about of the different merchant stories that we were trying to solve. And now I want to take a step back, right? Because all of these sound like great ideas, right? But how did we actually go from an idea that a data scientist or an ML engineer had to something that was running in production, right? And that's where I want to kind of finish our story today. Right? The easiest way is to give you a high-level overview of the data infrastructure. All of Shopify's infrastructure is built on top of the Google Cloud Platform. We've had a very mature data platform that's been tried and tested over many, many years. Right? Typically, our data scientists process data using either Spark, SQL, or Flink for streaming. And so that vertical tower that you see, the data processing tools, that's been existent for a long time now, for a few years now. Right? But what we quickly realized is, specifically for production ML use cases, this wasn't enough, right? It was needed, but it wasn't enough, right? We needed some additional capability for ML. And so that's where our new ML platform comes in, right? And this is like, I want you to meet Merlin. We actually have a blog post. So if you go to our Shopify tech blog, there's a lot more detail about our machine learning platform. But at a high level, it's built on top of our production Kubernetes system. And then on top of that, we use this open source library called Ray to build dedicated environments for each project or each data scientist, which we call a workspace, right? And workspace is essentially the ability for a data scientist to control both the hardware as well as the software that their code is running on, right? So I can go in there and say, hey, give me, I don't know, N CPUs, X GPUs, these kinds of GPUs, this much memory, and then I'll say I need these kind of libraries installed on it, and then I can say I need horizontal scaling, auto scaling, all of that, right? And the platform abstracts all of that away. So I give them a configuration file, they take that and they create these workspaces for me. And one of the biggest advantages that we found by doing this is that as a data scientist, for me, I'm pretty much doing my dev and staging environments look the same as what it would look in production, right? It's the same hardware, it's the same software. It even has access to the same production data, read only, of course, right? But there's no difference now, right? There's no difference between production, staging, and dev. It's literally the same thing. And that's amazing, right? And then on top of that, we have Jupyter access in each of our workspaces. And Ray allows us the ability to do distributed computing. So I can do distributed training on TensorFlow, PyTorch, XGBoost, whatever it is, whichever framework you want to use for your modeling, you can do that on Ray, right? And all of this has made it extremely easy for us to move from dev, staging, experimentation, and then finally into production, right? And so we did all that, and then on top of that, we have like additional tools like we have a model registry, feature store, we have online inference service, all of that built in our ML platform. And so this kind of like, it's super easy for me to now spin up the workspace and then kind of experiment on top of it, right? And so we come now to the end of our journey, right? I did want to emphasize that all of these successes that we've had has been the result of multiple teams kind of interacting with each other. I'm standing here today talking about these wins on the shoulder of some of the best colleagues that I could ever hope to work with. And we've had many, many, many learnings along this way. Like all of the things that I spoke to you about, this has been a couple of years of learning and iteration for us. And we hope to pick up the pace, right? Like we're hoping to iterate much faster. The platform's changing. We are learning how to kind of improve the way we do things. And we're hoping we're able to deliver a lot more success for our merchants. And with that, I come to the end of my presentation. And if I have the time, I can answer a few questions as well.
Thanks a lot for that insightful session. Yeah, we are running slightly over time, but I think we can still spend a couple of minutes for the Q&A session. Is there someone with questions?
So, thank you for the wonderful talk, first of all. So I was wondering, like, when you spoke of the audience set, and you said that you're basically looking at people who have already, say, for example, bought a dog bed, and so you kind of anticipate that they're going to buy it again. But also, like, did you consider like user similarity, looking at the past purchases of the users and be like, this person is probably going to buy a dog bed too? Like, was that one of the things considered?
I mean, yeah, that's mostly what we do, right? So we look at all of our previous users, right? We look at all their purchase history. We basically figure out, like, let's say, right, like, again, very naive example, right? Let's say we found that people who bought dog food regularly for the last 6 months are more likely to buy a dog bed. Then if I find somebody who's had regular purchases of dog food, then yes, I'm going to say, hey, this person looks similar to those other people. And so, yeah. And then on top of that, once we send over that audience set to the online advertising platform, they have similarity, like likelihood, similar. So I can send them a list of, I don't know, 20,000 people, and they can find similar people to that 20,000 people as well, right? So it happens at multiple stages.
Thank you. I mean, there's one more question.
Okay, thank you so much. It was amazing. My question, you said ad platform. Is it the secret? Which platform are you using?
Right now I think we support integration to Facebook. I think we're going to launch Google Ads as well soon.
Who is paying for that? The customer or you?
Paying for what?
Advertising.
The customer. Like, they're already running ads. Like, our customers are already running ads on Facebook with Facebook's own targeting system.
So you provide.
So this is just a different way for them to manage their Facebook campaigns. They're already running ads on Facebook. This is just, hey, run it with our targeting so that you can see better return on investment for your ad spend.
And you include that in the membership fee.
For a certain section, I think right now Audiences is only launched to a certain subscription tier in the US only, but we plan to roll it out to other locations and other services.